When we think of electricity flowing through conductive material, we might picture it like water flowing through a pipe. Here, water consists of many particles, and the larger the pipe, the more the particles can flow, and the more pathways they can take on their journey from one end to the other. But if we could make water flow through a pipe so narrow that only a single particle could pass through it, we could control, with great precision, the route that particle would take. But is the same true of electricity, where the electrical current is carried by many electrons? Is it possible to precisely control the pathway of an electron by creating electrical circuits on a nano scale? And if we could, how might that change the way we use electricity in the future? At the University of Oxford, there is a team dedicated to finding out how electricity behaves when it flows through a single molecule. They've developed a method for making nanoscale electrodes from ribbons of two-dimensional graphite called graphene. They use electrical pulses to break the graphene, creating a gap just big enough for a single molecule such as benzene, which has a ring-like structure. Once the molecule is in place, they get to work trying to reveal electrical phenomena that can only be observed in such tiny structures. It's the very first step towards their long-term aim of using these phenomena to build nanoscale electronic components. One of these electrical phenomena is quantum interference, which makes use of the quantum mechanical wave-like properties of electrons. For instance, when a single electron is offered two pathways, due to its quantum behaviour, the electron can take both pathways at once. And if those pathways connect, the electron waves meet, exaggerating or cancelling each other, just as ripples on water do. At Oxford, the researchers believe that if it's possible to control how these waves meet, and whether they exaggerate or cancel each other, it's possible to use quantum interference to create a simple, energy-efficient switch. And that's just the start. Conductive wires, insulators, transistors. With greater control and understanding of electricity, it may become possible to make a full range of tiny and highly energy-efficient molecular components to replace current technology. For more fascinating science, visit our website, subscribe to our channel and find Oxford Sparks on social media.